Let's start with this webinar. As I said, my name is Fernando. I work for the company Matrikon OPC. All right, we are located in Barcelona, Spain, and I will be hosting this webinar or this live training about the software MatrikonOPC Tunneller UA. Okay, so the idea of this webinar is to understand how we can get the most out of our MatrikonOPC Tunneller if we already have the software. And if you don't have the software, is to understand better what the software does. Okay, so this is a software that Matrikon has been selling for many years, but it has the newest version has many new functionalities that probably most customers are not aware of. Okay, so well, at the beginning of the presentation, we will explain briefly what is the tunneler, and then we will go right into the demo. Okay, the demo part. We will host some two virtual machines, and we will play with the software a little bit. All these webcasts will be recorded, and you will receive the video of this presentation, so no need to worry about recording by yourself, because we will send it to you at the end of the webinar. Also, we have a chat in the Zoom. We have a chat, so you can type your questions. There is a colleague here called Pedro working with me. He will be reading the questions, and at the end we will try to solve them all. Okay, and also we will play with some software solutions, so for simulation, and also with the tunneler itself, and we will be entering in the chat the links for this software. So at the end of the presentation, you can also, even by yourself, you can download it and play with it. All right. So let's start with the presentation. Okay. So in this training, in the overview, like, we will talk first about what is the OPC basic architecture. You know that the tunneler is a software that allows you to move data between OPC applications. So we'll explain briefly. Probably you already know, of course, what is the OPC technology, but we will go into a brief introduction of what it is. We will talk about the OPC Classic. As you know, in the OPC technology, we have two different standards. We have the OPC Classic, and we have like the evolution of the OPC Classic, which is the OPC UA. So we will talk about the limitations that the OPC Classic has, and the connection that the OPC Classic has with Windows. All right. With these limitations, we will go then into explain the tunneler, the MatrikonOPC Tunneller solution, and from this part of the demo of the training, we will go and play with the software, and we will make some simulations of typical situations that we can have in industrial connectivity projects. So if you don't know Matrikon, the company, we are dedicated to industrial connectivity solutions. Basically, we move data from industrial devices, from PLCs, from DCS, from RTUs, into software applications like a SCADA system, ERP, MES, and so on. Right? So well, let's start with this training. So you can write your questions in the chat, and I will read them at the end. So thank you very much for saying hello at the chat. At the end, I will read it. It will be hard to read during the presentation, but I will do it at the end. Okay, so let's start first about what is the OPC technology, right? The OPC technology basically is a communication standard. It was created in order to solve the connectivity challenges that we have in the industry. You know, in any industry, we can have PLCs, DCS, RTUs, databases. All these devices or data sources normally are coming from different vendors. We can have PLCs from Siemens, Omron, Honeywell, ABB, Omron, I don't know, Schneider. So we can have all different brands of industrial devices, and we need to share this information with applications like SCADA systems, like historians, like MES, ERPs, databases in the cloud. So the idea of the OPC technology is to make this communication simple, right? Is to standardize the connectivity in a technology and not in a specific product, because each device or each data source that we can find here in the picture below, each PLC speaks a different language or a different communications protocol. Siemens PLC, they speak their own protocol. The Schneider PLCs, they speak Modbus protocol. Allen Bradley PLCs, they speak their own protocol. So the idea of the OPC technology is to standardize the data connectivity between these data sources below and the applications on top. So at the end, using the OPC technology, we can connect any device from any vendor that speaks any communications protocol with any software application that exploits or that visualize this data, right? So at the end, the idea of the OPC technology is to make easier the connectivity without taking care who is the vendor of the device below or who is the vendor of the software application on top, okay? So how we can do this, because we have an architecture, or OPC has an architecture that is client and server, okay? So in any OPC architecture, this could be OPC Classic or OPC UA, we can have we will have an OPC Classic and an OPC Classic client or OPC UA client and an OPC Classic server or OPC UA server, all right? So the communication is all the time a client talking with a server. This server, basically what it does, it works as a gateway from two technologies. It works as a gateway from the protocol of the device. So this data source could be a Siemens PLC, Omron, Allen Bradley, Schneider. So the OPC server will translate from the protocol of the device into OPC. And then once it translates the data into OPC, any OPC client can read this data. All right, so the way it works is that the OPC clients ask for the data to the OPC server. The OPC server makes the translation of the petition, and the OPC server asks the data to the PLC. The PLC answers with the information, and the OPC server sends this same data to the OPC client. All right, this is the OPC basic architecture, and we can find it in any OPC connectivity project that we have. We have an OPC client talking with an OPC server. All right, so we say that basically there are two communication standards. We have the OPC Classic, which is the standard we have been using for the last 20 years. And the OPC Classic functionality, it solves the challenges, the connectivity challenges that we mentioned before, all right? Accessing to multiple data sources without taking care who is the vendor or which communication protocol this device speak. Also allows us to move data between devices, okay? With the OPC technology, we can move data from one PLC of one brand to another PLC from another brand using two different communications protocol. We can handle redundancy, okay? We can have redundant architectures. We can have projects where the data is critical, and we can build redundant architectures. All these functionalities can be solved with the OPC Classic technology. And of course, this is a communication standard that was created more than 20 years ago. So of course, it has some limitations, right? So one limitation that the OPC Classic has is that it's based on a specific technology, right? Where in the moment the OPC Classic standard was created, instead of using their own communication stack, instead of using their own way or their own technology to move data from one application to the other, they took advantage of an existing technology, which was the COM and DCOM technology of Windows. All right, so that's why we say that the OPC Classic it depends on Windows. It relies on Windows. So if we have any OPC Classic architecture, it's mandatory that these applications are running on Windows, because the only way we can connect an OPC server with an OPC client is through the COM and DCOM of Windows. We will explain that later. Okay, so as we are attached to Windows, talking about OPC Classic, all the security is based in the operating system. Okay, all the security to connect an OPC client with an OPC server is based on the permissions that we give to the applications, the permissions we give to the OPC server, the Windows user permission, the permission we give to the OPC client, and so on. So all the security in OPC Classic relies on the operating system. Okay. And also another limitation that the software the technology has is that it has a very simple information modeling representation, right? We will see later, or if you have worked before in OPC projects, you know that the standard is to have a name of the tag, to have a value, to have a quality, and a timestamp, okay? You have like 4 fields, and that's it. You cannot have more than that, okay? So this is also, we can say that this is a limitation that the technology has, all right? So we mentioned what is the COM and DCOM, all right? So we say that this is a technology that was created by Microsoft more than 20 years ago. So the OPC technology uses the COM and DCOM to move data between the OPC server and the OPC client. So an OPC server is a Windows application, and an OPC client is another Windows application, just like Word, just like Excel, just like any other Windows application, all right? When we move, for example, when we copy data from Word into Excel, we are actually using the COM, the COM of Windows, all right? Because this is a technology that Windows used to communicate to software applications. So the important thing here to understand is that when we have all the applications running under the same computer, we are using the COM, all right? When we have them on different computers, we use the call it DCOM, all right? So if you have worked in OPC projects working with OPC client, maybe you have deal with some DCOM issues, because basically the tunneler was created to solve all these DCOM issues, all right? But well, just to make it clear, when we have everything under the same computer, we use COM. When we have the applications, the 2 applications running on different computers, we use the DCOM. Okay, so what happens when we have everything running under the same computer? When we have everything running under the same computer, as we say, the OPC client is a Windows application, and the OPC server is another Windows application. So they don't speak each other directly. They speak through the COM service, all right? The COM. And the COM of each application, they speak each other in order to share data. So we say that the security in OPC Classic is based on Windows user. So when we have everything under the same computer, normally we don't have problems. That's why we never hear about COM problems. We always hear about DCOM problems. But when we have everything under the same computer, normally these 2 applications, like OPC Classic Client and the OPC Classic Server, are being executed by the same Windows user. So both users has the same permissions and so on. So when we have everything under the same computer, there is no problem with the configuration of this communication. It's just opening the client, connect to the server, and start to visualize data. Okay, what happens when we have them on different computers? Okay, well, this is where we need to configure this DCOM, all right? So the DCOM has some limitations, all right? And we will see them later. But basically, this is for cases where the OPC client is installed in another computer, differently from the OPC server computer, all right? These computers could be on different networks. These computers could be with a firewall in the middle. So we will see that configuring the DCOM is something tricky, all right? We actually give a training about the OPC technology, and we dedicate almost 4 or 5 hours of the training to learn how to configure the DCOM. So basically, configuring a DCOM communication is configuring the security of OPC Classic, okay? Basically, what we need to do is to give permissions to this OPC client, Classic client application to connect to the OPC server. The Windows user that is executing this application needs to have permission to connect to the OPC Classic, and the other way around. So there is a user manual where you can follow of how to configure the DCOM, but this is something that is very tricky. All right, and it's very tricky because it has some limitations. So which limitations? that the DCOM has. So the most important one, I think, is that the DCOM is not compatible with firewalls. All right. If we want to have an architecture like this one on the right, the server in one computer, the client in another computer, probably this computer is in the OT network and this computer is in the IT network. Or in an upper network. Okay, so normally what is the most of the cases we have firewalls in the middle, but the thing is that the DCOM is not compatible with firewalls. All right, so why is not compatible with firewalls? Because the DCOM uses random ports. Every time that an OPC Classic client tries to connect to an OPC server, to an OPC Classic server, it uses a random port between port 1024 and 65,535. All right, so there is no way, using the DCOM, there is no way we can know which is the communication, the port that the communication will use. All right, there is no way. So we have many technical support cases where the customer contact us like, no, but I cannot connect the OPC client to the OPC server. There is a problem. I only did a reboot of the computer and it was working before. All right, so we asked them, do you have firewalls in the middle? Yeah, I have firewalls, but before it was working. Well, probably the port was open. That port was open in that moment, but then when you rebooted the computer where the OPC client is, he will select another port, and there is no way to know which port it is. So then probably he tried to connect to the OPC server computer, and that port was blocked in the firewall. All right, so this is a huge limitation because at the beginning, when the OPC technology was created, it was not normal to share data between different networks, to share data across internet, to share data to a control center. All right, so now with the emerging technologies, we see that this is a huge limitation. Because we not only we need to share data with computers in other networks, but also we need to do it in a secure way. And we cannot share data in a secure way if we cannot implement firewalls. All right. So at the end, we say that DCOM and firewalls are not compatible. Okay, so also there is another reason why the DCOM is not something we currently recommend. Is because of the DCOM hardening. All right, so this is basically this is a news. Probably you have heard about it or you have received some mail notifications. Basically, Microsoft identified a vulnerability in the DCOM. All right, so since last year, they started to make changes in the DCOM. So in all the new Windows versions, once you install the Windows, the patch, the new patch or the new upgrade of the operating system, there will be some changes in the DCOM. All right, so these changes that Microsoft will apply might be affecting all the DCOM communications. All right, it depends on each case. We'll explain that briefly later. But if you want to know more information about it, you can contact us at the end. You will have my email address and you can contact us and we can study your OPC architecture or your OPC infrastructure, and we can let you know if you will be affected by this or not. Basically, what they found is a vulnerability in the DCOM. And when you connect an OPC client to an OPC server, there is something called the authentication level. So normally with the basic authentication level, which is called connect, you can make any DCOM communication. But now Microsoft, since March this year, they will make mandatory to support the authentication level less than packet integrity, okay? And not all the OPC applications that are developed, they support this. Okay, so in those cases, if the server and the client does not support this level of authentication, if you install the new Windows patches, you will be affected by the DCOM hardening. Okay, so this is another reason of why we don't currently recommend the DCOM. These are the two the operating systems that will be affected by the DCOM hardening, and we will share also this presentation. We can share it to you at the end. Okay, so what are the solutions? Okay, we saw that the OPC Classic has some limitations, that most of them are related to the DCOM. And of course, the way to move data between OT and IT normally is the OPC standard. So how can we solve this? So the solution is the software we wanted to mention today, and the one we will make a demo about it, which is the MatrikonOPC Tunneller. Okay, so basically the MatrikonOPC Tunneller is a software that you installed in both computers. You install in the OPC classic client computer, and you install in the OPC classic server computer. Okay, you install the tunneler in both ends, and from the OPC classic computer, the only thing you need to do is to enter the IP address of the server computer. Once you do that, automatically the tunneler gives you the list of all the remote OPC servers as you have it in local. All right, so basically it creates like a bridge or like a tunnel, like the software name, between the two computers, and you don't need to worry anymore about the DCOM. Okay, so this is one of the main functionalities of Tunneler. This is the one that you probably have heard about it, but we will mention two extra. Okay, but first let's try to make a demo about it. All right, so basically we will simulate this same situation. One of the advantages is that the Tunneler makes a bridge between the two computers using a single TCP/IP port. All right, and we can select the port. This is why we say that the tunneler is compatible with firewalls. So first, we don't need to configure the DCOM. We don't need to worry about DCOM anymore, and we can select which port we are going to use to communicate. So we select the port, and then we can tell the people from IT, okay, open only this port in the firewall, and that's it. Okay, so let's try to make a demo. So I have two computers. I have two virtual machines. One has two OPC Classic servers. Remember, here we are talking about 100% OPC Classic architectures. So we have two OPC Classic servers, the MatrikonOPC server for simulation and the MatrikonOPC server for Modbus in one computer. And I want to share that information, that data with an OPC client that is located in another computer. So we saw that if we want to do this, we have two options. We can configure the DCOM, or we can use the tunneler. So with the tunneler, we can make this communication easier, and we don't need to worry about DCOM configuration or firewalls in the middle. All right, so first I will show you this computer where I have the MatrikonOPC server for simulation and the MatrikonOPC server for Modbus. There are two OPC Classic servers. All right, let me open my virtual machine. Okay, all right, this is the virtual machine. Let me minimize this. Okay. This is a virtual machine, and this is the software MatrikonOPC Explorer. This is just an OPC client for testing, okay? So this is just to show you that I am reading two tags, one from Modbus. Actually, I'm using a Modbus simulator. This is a simulator that acts as an OPC, as a Modbus slave. So with the MatrikonOPC server for Modbus, I'm reading the data from this PLC that simulates to be a PLC. And also I'm using another OPC server that simulates OPCTA data, okay? I'm reading data from these two OPC servers, and the idea is to share this same data to an OPC client that is located in the remote computer, in the other computer, all right? So if we go back here to the architecture, here we are reading in local the data from these two OPC servers, and we want to do the same, but from the remote computer, when a computer located in another IP. All right, so if I minimize this, of course, I need to have the tunneler installed here in this machine that I show you. I need to have the tunneler. I did the installation before of the tunneler, and we will open the configuration later. But here I have the tunneler. As I said, when we create this connection in the server side, we don't need to do anything. We just need to install the software, okay? And of course, we will use the port that is coming by default. We can change it later. All right, so if I go back now to the OPC client computer, all right, here is where I want to read data from that OPC server, okay? So if from those two OPC servers, sorry. So here I'm opening an OPC client for testing, same as I did in the server computer. So if I want to connect here, I can see the list of all the OPC servers I have in local, but I don't want to connect with an OPC server in local. I want to connect with an OPC server located in another computer. So if I don't have the tunneler, the thing I need to do is to configure the DCOM. So for example, if I want to connect through the DCOM, I need to enter the IP address of the remote computer, 3154, and I need to tell them, okay, to which OPC server I'm going to connect. Let's try with the simulation. So if I try to connect, see, I'm getting an error, all right? So the error is that DCOM error, in this case, will not create instance. This is the typical error that we get when the DCOM is not configured, all right? And this is like a nightmare to solve. So let's try it with the tunneler, okay? So let's open the configuration of tunneler. So if we write tunneler, or if we go to Start, MatrikonOPC UA tunneler configuration, right button, run as administrator, okay? I'm opening the tunneler. So basically, if we go back to the architecture, now I'm in this machine, all right? I just opened a MatrikonOPC Explorer in the client machine and tried the connection with DCOM, and it failed. So now I'm opening this tunneler in order to create this connection. So we will see how we can solve this same connection, but using tunneler. All right. Okay. Perfect. So, all right, this is the software configurator of tunneler. All right. We see that it has 3 different options. So now we will focus on this one. All right. When I have an OPC Classic server, this could be more than one. Like this case, I have 2. And one OPC Classic client, which is a MatrikonOPC Explorer. So I'm opening the tunneler in this machine, and I need to configure the connection with the other one. So I go here to Classic, and I have 2 components in the tunneler. I have the client side and I have the server side. So as I am in the client computer, here I'm using the client side gateway configuration. If I need to change anything in the server side, I need to go to the other computer and check the component of tunneler server side. Okay, when you install the tunneler, automatically install the two components. Okay, so the tunneler can have unlimited connections. This could be an OPC client connecting to 10 different or remote OPC servers located in 10 different machines. So here I can be creating a lot of connections. Okay, so the first I do in order to create the connection, I press here in the plus add remote tunneler connection. And here it asks for the IP. All right, let's put the IP of the server computer, 3.154. Okay, I am the IP 151. I will connect to the IP 154. Okay, through the port 21379. This is the port that the tunneler uses by default. We will show later how can we change it. But here in the client side, we are selecting that the port by default. And we can also select how many communications retrieve attempts we want to achieve, all right? So one advantage that the tunneler has is that I can put retry forever. So if I have a network failure, for example, between IT and OT, the tunneler can keep trying connecting all the time. And once the network failure is solved, automatically my SCADA will start reading data. We don't need to manually go into the SCADA and connect again to the OPC server. The tunneler will do that for us. All right, so I press OK. All right, these are the typical timeouts for the tunneler. And if the IP address is correct, automatically I will see all the OPC servers that I have in the remote machines. So we recommend that if you want to open a CMD, you can make first, if you want to make sure, you can make first a ping of the other computer, and just to make sure that you have connection with that PC, all right? Sorry, 3.154.154. All right, so first you check that you have a ping. So in my case, was successful because I got the list of all the remote OPC servers. And we see here that also I got the list not only for the OPC-DA servers, but also those servers support some of them OPC HDA, which is historical, or OPC A&E, which is alarms and events. So the 2 relevant for me are these 2, the MatrikonOPC simulation and the MatrikonOPC server for Modbus, this one, all right? So I already created the connection. So if I go back to the presentation, if I go back here, I'm in this PC. I create the connection to the 154 PC, and automatically I I'm now seeing all the remote OPC servers as I have it in local. So in order to test it, I need to go now to the Matrikon OPC Explorer in order to test reading data. Okay. So if I do this, I minimize the Matrikon tunneler. I will refresh the Matrikon OPC Explorer. All right, because I have new connections. And now, if you see, we have the new connections created. Okay, so we didn't have to do anything with the DCOM or any DCOM configuration. We just created a connection or a bridge to the remote PC. And now, if you see here, all this list is in localhost. So this OPC client or my SCADA, remember that this OPC Explorer is an OPC client for testing, but then this will be your SCADA or your OPC, any OPC application who will visualize the data. They will see the OPC server as they have it in local. So let's try to connect to the Matrikon OPC server for simulation first, for example, and let's add some tags, okay? So here I'm exploring the folders at the OPC server for simulation. I will add only one tag just to check that everything is okay. Okay, so yeah, I'm receiving the tag, the random int1 with value changing every second. The quality is good, perfect. So if I try to connect to the OPC server for Modbus, which was the other one, and I will try to add also the other tag that I was reading in the other PC. Let's try to add just one. Okay, if I add that one, I check that the quality is good. All right, it's a tag that is changing every second as well, and everything is running fine. So in a very simple way, we solve all the DCOM challenges. So remember, using the tunneler for an OPC DA to OPC DA or OPC Classic to OPC Classic connection is that simple. You only need to install the software in both ends and automatically from the client computer to create the connection to the server computer. All right, so just to have some relevant information about the software. Here, if you minimize the client side, you can also see the server-side gateway configuration. So the tunneler has also some advanced functionalities that might be useful in some projects. Okay, I will mention the relevant ones, the more relevant ones. We can mention the encryption. Okay, for adding more security, we can encrypt the data, and only the OPC tunneler client can de-encrypt that data. All right, for more security, we can add encryption, or we can also restrict the access to some OPC servers. So if you see the list here of OPC servers I have, probably I don't want to share all of them because I'm not interested in the, I don't know, in the OPC server from Triangle Microworks. Probably I'm not interested in sharing that with another computer. So I can restrict the list. Yeah, if I go here to restriction, I go to edit settings, and I can just select which OPC servers I can do. I need to create an access list, which is called an access list. And I just need to tell them, okay, I just select which is the OPC server that I will share. All right. Okay, so this is just a functionality that the software has that might be useful for some projects. All right. If I want to change, for example, the port number, if I want to change it, I go to the server side of Tunneler in this case, but I need to go to the server computer, and here is where I change the port. All right, so the good thing is that we can select the port. So you can tell the IT people, okay, so you tell me the port. I will configure it in the software. So they tell you, okay, the port is 22,000. Okay, you go here into the server side, you put 22,000, and then when you create the connection here from the Tunneler client, you put also 22,000. And now all the communication will run through that port. All right. What else is relevant about here? For example, we, of course, as any other software, we have logs. Okay, if we want to know, okay, we are having an issue with the communication, we can go here into the logs, and we have different level of logs. We can, for example, try to reproduce the problem and put the logs in high. Okay, so the logs are being stored here in this path. So if you go here, I have it here, local disk, program files, common files, Matrikon, and common. Here you have all the logs of the software, in this case from Matrikon software. If I open here, this one is just a test file. a TXT file, and here I have some information about the communication. Okay, now the logging is in low, but you can also check here if anything is happening. You can check the license and so on. Here, for example, I have a trial license that lasts for 29 days. Okay, perfect. So this was just to show that we can easily connect from a remote OPC client without configuring the DCOM. So remember, no DCOM, no problems also with the DCOM hardening changes. So we can migrate Windows to the newest version, and if we are using the tunneler, we won't be affected for that. Okay, if we go back to the presentation. All right, let's go back. Okay, so as you can see, like with the OPC Classic, we have some limitations. We mentioned some of them, and of course, the idea of the typical connectivity projects has been evolving to sharing data not only with local computers, but also with computers located on different networks, connected through internet, sharing data from different plants into a control centers. Okay, so the requirements of the industry has been changing. Okay, that's why the OPC Classic was getting behind on that, because as it was attached to DCOM, it was not a good solution to share data across firewalls, across different networks, across internet in a secure way. All right, so that's why the OPC UA technology was created. All right, so probably you also have worked with OPC UA. We will mention briefly the difference. Okay, so the main difference about the OPC UA is that the OPC UA created his own communication stack. Okay, it didn't use an existing technology like COM and DCOM. It created their own communication stack. That's why we say that the OPC UA is not attached to Windows, because the OPC UA does not need the COM and DCOM. It's not using the COM and DCOM. This is the reason of why we can see a PLC with an OPC UA server embedded. Okay, or a microcontroller or a sensor with an OPC UA sensor embedded, an OPC UA server embedded. Of course, we don't have Windows in a PLC. So why? It's because the OPC UA technology does not use the COM and DCOM anymore. So the main advantage of the OPC UA is that it's not attached to Windows anymore, which means that the security is different. We don't use Windows users anymore. We don't need to configure permissions for the Windows users that are executing the applications. Normally, the security is based on digital certificates. Okay, you need to exchange digital certificates between the two applications. Okay, so what we can see now in the industry is that we normally have like a mix of technologies. Okay, as you can, if you have experience in the industry, like we have like two layers. Okay, we have the OT layer and we have the IT layer. Okay, so the OT layer moves very slow. Okay, we have PLCs that has been running for 30 years, 20, 25, 30 years. But in IT, we migrate the applications, we upgrade the applications every 2 weeks, every month, every 2 months. All right, so there are two layers that are moving in so different speed, to so different speeds. So it's impossible that we can replace all the OPC Classic applications with OPC UA. Okay, so some of the applications are being migrating slowly, because we say, okay, if we are not attached to Windows anymore, why we don't use OPC UA in 100% of the projects? Because not all the companies that provides OPC applications, not all of them, they already developed an OPC UA application. And of course, you know that new technologies needs some time to be implemented. Okay, this is the reason of why the new version of Tunneler also can support mixed architectures or hybrid architectures. All right, so we already mentioned the first functionality, or the main functionality of Tunneler, which is this first one, but also the Tunneler supports being a gateway between the OPC UA and the OPC Classic. Okay, if, this is important to say, if we have an OPC 100% OPC UA architecture, we don't need to worry about DCOM. We don't need to worry about DCOM hardening. If you have an OPC UA server connecting to an OPC UA client, you only need to open one port in the firewall. That's it. But you don't need to worry about being affected by the DCOM hardening. But you can also have mixed architectures. Like, for example, you can have an OPC UA server embedded in a PLC, which is this is the second case, but your applications supports only OPC Classic. You can use the tunneler as a gateway. So this tunneler connects over OPC UA to this one, and then it connects in local using OPC Classic. Okay, so we can have also the other way around, which is if the OPC server is Classic, but the OPC client is UA. So let's try to configure that in order to show you how you can easily migrate or integrate OPC Classic with OPC UA. All right, so let's do first this example. Let's suppose we have some OPC Classic servers and we need to read data in an OPC UA client. How can we do it? Basically, we use the tunneler in the functionality of wrapper. Okay, so this is the architecture. These are the same computers that I was using. These are the same OPC Classic servers, but we want to expose this data over OPC UA. All right. So let's go back to the demo. All right. Let's go back to the computer. Machine 154. Okay. This is the server side. All right. So we need to configure the tunneler in order to share this data over OPC UA. All right. So if I open here the tunneler, okay, this is a Windows 7 tunneler configuration panel, right button, run as administrator. All right. If I open here the tunneler, what I'm gonna do, if you see this, what I'm gonna do is to configure this tunneler in order to share the data in OPC UA. Okay. Another advantage of tunneler that we saw before and also applies to this is that we don't need to deal with the tags. Okay, the tunneler creates a bridge between the two computers, and you don't need to add the tags again. You don't need to take care if there are like 10,000 tags, 5,000 tags, 100 tags. The tunneler will create a connection, and you will see the same tag structure in the other computer. So the same happens here. So we will share this data over OPC UA and we will keep all the same tag structure. All right. Then we will, in order to make the test, we will use an OPC UA client for testing. It's another application from Matrikon that is also called Explorer, but in this case, it's a Matrikon OPC UA Explorer. So these are these tools are very useful because allows you to test. They are free. The OPC UA Explorer and the OPC Explorer, they are free, and you can use it for troubleshooting as well in any project. Okay, so we already configured the Classic to Classic. Now we are talking about the last part. If we have an OPC UA client, but the OPC server is Classic. All right, here I can see that I already have the Matrikon OPC server for simulation. Let's try to add another one. It's just a matter of press plus. We select the OPC server for Modbus, and we just press add. All right. Once we do that, this means that we will expose over OPC UA these OPC Classic servers. Okay, the Matrikon OPC server for simulation and the Matrikon OPC server for module. We will expose through this URI. All right. So normally, if you have worked with OPC UA, this is the URI that you will use to connect. Either you enter the IP and the port, or you just copy this URI. All right. So I will start this service of this software. Then we will talk about security, but in a very brief way. So this OPC UA server supports different endpoints. Okay, it supports none, and also supports endpoints where we need to exchange certificates. So if we want to create a secure connections and we don't want them to connect without the certificate, we need to disable this none. All right, because with sign and encrypt, they need to, the two applications, the client and the server, they need to exchange digital certificates. And we can also say that no anonymous user can connect. We need to create a user for more security. All right, so in this case, here we can see that this is the only information we need to connect. If we use the option none, there is no certificate exchange. If we disable this one, we will do the certificate exchange. And also here I can change the port. By default it's 21381, but I can change the port. All right, so I'll minimize this, and I'm going to the other computer. I'm going now to the client computer. So here I have the two. So I'm here in the client computer. I will minimize everything I have. And what I need now is a MatrikonOPC UA Explorer, because I need to test that the tags are being exposed in OPC UA. As you can see, this is a different configuration. For OPC Explorer, we press just add new server and we enter the IP of the server computer. 168.3.154. Okay. And we say that the port number was 21381. All right. So we press here. All right. Oh, it is. Oh, sorry, I didn't put the 3.1.3.154. Okay, and now, yeah, it found the OPC UA server, okay, and I have the three endpoints, okay. You can see that here I have the none, all right. I press with the anonymous user, I press connect, and now I'm connected, okay. Here I can explore the tags. If I open this folder, here I have the two OPC servers, the simulation and the Modbus. So remember, I'm reading now over OPC UA, all right. So we could convert the OPC DA servers into UA just by adding them in that list. So I will read one tag of the simulation, and I will read one tag of the Modbus. All right. Sorry. Okay, so for the Modbus, I will read one tag. Okay, so as you can see here, I didn't have to add the tags manually. I just can browse all the tags, all the address space that the OPC Classic server has, and I'm reading the tag with good quality. I have a source timestamp, a server timestamp, and I have everything, right? So in a very simple way, I could convert the OPC Classic servers into UA, all right? That's it. Let's go back to the presentation. We did this. We configured only one license of Tunneller, only one site, and we could convert these OPC Classic servers into UA. So this part also has their own login. If we want to see some login, we go here into login, and here is where it's being stored all the OPC UA communication. All right. If we create a connection with the security, here there is one part that is called the certificate store for trusted certificates and for rejected certificate. So if we create a connection with security, we go here into rejected, and we just move the certificate from rejected into trusted. All right, we just go there, press okay, I trust in the certificate, and in the next you only do this in the first connection, and that's it. You can make the communication just as we did it with the option without security. All right, so we just configured this one on at the bottom. All right, I had two OPC Classic servers and one OPC UA client, and I convert them into UA. So the Tunneller has no limits. You can have here 3 OPC servers, 3 OPC Classic servers. So we use this a lot when the customers, they already have an SCADA that supports OPC UA, but normally, for example, they have a DCS that is only OPC DA, right? So, okay, you don't need to wait for the DCS vendor to upgrade the OPC Classic server. You can make the communication using UA just by placing one license of Tunneller in this site. All right. And we are just missing the other test. Okay, the other test is what happens if we have the other way around, that we have the OPC server that is UA, but our OPC client is Classic. All right, in this case, the functionality, we call it a proxy, and we will show how to configure it. All right, so for this, I'm gonna use an OPC UA server from another vendor, the OPC UA server from Vinode, and I will try to read the data into the MatrikonOPC DA Explorer, which is Classic. Okay, so normally we cannot make this communication because this is OPC UA and this is OPC Classic, but we will see how the tunneler can convert from OPC UA to OPC DA. All right, so if I go to the server computer, which is this one, here I have an OPC server that is called vnode. Okay, let me just start this vnode. Okay, I will start the modules that the software has. All right, in order to have a full functionality of the OPC UA server. So in this case, I am in here. I am in the server computer. I'm just restarting the service in order to have full functionality. And I'm gonna test how to read data in OPC DA in the other computer. So if I minimize this, this is the configuration of the OPC UA server. So basically, I will want to read these three tags. I have a tag called level, pressure, and temperature. This could be an OPC UA server embedded in a PLC. So I want to read these tags in OPC DA. If I minimize this and I go to OPC client computer, I will minimize this. Okay, we can test first just connecting to that OPC UA server. From the OPC UA Explorer, we can just test how I can connect. So if I minimize this and I go to the OPC server computer, I just need to know the port. Okay, so the port that the vnode uses is the port 3005. All right, it's located in the same IP and port is 3005. So here in the computer, in the client computer, I put instead of 21381, I put 3005. All right, and it found the vnode OPC UA server. Okay, only with one endpoint. I press connect. All right, I press objects, plan one, and I have here the tags, the level, the temperature. Okay, so this is just an pure OPC UA connection. All right, but I don't want to read over OPC UA. I want to read these same tags, the temperature, the level, and the pressure in OPC DA. So I need to configure tunneler. So if I go here to the tunneler configuration here in the client, I go here to the tunneler configuration. If I go to home, now I'm in this case, like I have the OPC UA server and I have the OPC Classic client. When you buy the new version of tunneler, you have the three functionalities included. Okay, you can use the functionality of your choice. All right, perfect. So now I need to configure this in here. All right, Classic client to UA server. All right, so if I create here a new connection, I need to, let me delete this one because it was old. I will put the same, the OPC server computer 3154, and the port of the vnode is 3005, right? So I added, it found the OPC UA server with this URL. Okay, I'm connecting through the anonymous user and I press create. So basically what the tunneler is doing now is creating a service that will create an OPC DA server in local. So it says that it's creating an endpoint and it needs to download or assign a certificate. We just press OK. We just accept the certificate. And now it is asking us as we will create an OPC DA server, which will have a Windows service, we need to tell them which Windows user will execute this service. So I will put the local administrator Windows user because I want this local administrator Windows user to execute this OPC DA server that the software will create. All right, so it already created. All right, the status now is stop. So I need to wait a little bit and now it's running. Okay, so now it created an OPC DA server in local. So if I go back here to the presentation, I'm now configuring this tunneler UA. I created the connection with the vnode in the remote machine. So what this tunneler does is to create an OPC DA server in local. So the Matrikon OPC DA Explorer or any OPC DA client can connect to this OPC DA server in local. All right, so now I opened this Matrikon OPC Explorer DA that I was using. I need to refresh because now I cannot see any new OPC server. If I refresh, all right, I need to have, or if the configuration was right, I need to have a new OPC server, which is this one, UA proxy Vino OPC UA server. Okay, I just press connect and I press add tags. All right, I go into objects, I go into plan 1. It's amazing because we don't need to deal with the tags. We just are exposing the tags without taking care which tags I was configuring. Just same address space that I had in the OPC UA server, I'm exposing it into OPC UA. I don't need to manually tell them which tags I want to add. I can just make browsing. And you can see now I'm reading these same tags that I was reading over OPC UA. I'm reading it over OPC DA in this case. All right, so this was the last demo. Okay, so we saw the 3 functionalities of Tunneller. Let me just go quickly into here. We saw these 3 functionalities: classic to classic, UA to DA, or DA to UA. All right, so using this Tunneller, you can configure these 3 functionalities. So let me minimize this and go back to the end of this. So here you have my contact details. You can send me an email if you have any questions about Tunneller. If you need to configure a communication, remember you can download the software from the website and you can test it. All right, if you have if you in your infrastructure, or if you have customers that has Deacon communication, you can tell them, okay, let's try the Tunneller. With a trial license, you can make it work, and then decide if you want to go ahead with the software or not. Or probably you have an older version of Tunneller and you want to migrate to OPC UA. You want the Tunneller to support OPC UA. You can also contact us for that. Okay, so before solving any questions, if there are any, we provide some trainings, okay, some specific trainings for the industrial sector, and that probably might be interesting for you. So in this case, we have trainings about industrial connectivity protocols. There is one training about Modbus, DMP3, IEC 104, IEC 61E50. We have another training about cybersecurity for industrial environments. Okay, we teach here how to move data from OT to IT in a secure way. What are the typical risks of doing that? How we can mitigate those risks? We have a training about OPC DA + OPC UA. There is a very practical training, and there is another one that is more for theory or for end users of these ones. All right, we have another one for developing SCADAs, and also one training about IoT. All right, in this training about IoT, we go into projects where we use other protocols, not only OPC UA, but also MQTT, REST APIs, which are protocols that we can also find in the industry. Okay, so also if you have some questions about these trainings, this is the calendar. We can share it to you later. This is the calendar for this year, and you can also contact me, and I will share the information with my colleagues from Better Industrial Training Center, and they will help you with any doubt that you might have. Okay, all right. So let me check into the chat. Okay, to see if we have any questions. Do we have questions? Okay, I don't know, Pedro, can you hear me? Do we have? Let me check if we have. All right, so I think Pedro has been solving some doubts, but we can also mention it. All right. Can this be, George is asking, can this be used in network with different IP addresses? Yes, exactly. So there is no limit. You just need to make sure that you can make a ping to the other computer and the port is open. All right, so the server and the client could be on different computers. You just need to make the proper router configuration just to make the NATs and everything. But if you can make a ping, the Tunneller can work. So yeah, the license are depending on the number of connections. Where are the limitations? No. For the licensing, the Tunneller is too many. Okay, there is no limits. Okay, we don't charge per amount of tags. If we go here, we don't charge per amount of tags or per amount of connections. So for example, here, this first case, if you have an OPC Classic client and you are connecting to 3 different remote servers. Here you pay only 1 license with 3 connections. You can make 1, 2, or 3 connections. We don't charge per connection. You need a license per computer, all right? So if you have 3 OPC classic servers running on the same computer, you also have only 1 license of Tunneler, but you just need a license per computer. All right. How many OPC servers for an OPC client? There is no limitation, as I say. The Tunneler runs only in application mode or as a service. This is important. The Tunneler runs as a service. Actually, there are 2 relevant services for the Tunneler. If we talk about OPC Classic, there is a service called Tunneler CSC, which is the client-side gateway configuration, and there is a service called Tunneler SSC. Okay, this is for the OPC Classic. These are the 2 services, relevant services for the Tunneler. Also for the OPC UA, if you convert from Classic to UA, there is this service, the UA wrapper. And if you do the other connection from UA to DA, it will create a new service. Okay, if I refresh this, I will see a new service for the Tunneler. This one, the UA proxy for Vino. All right, can the Tunneler bridge between other servers and clients? Yeah, and so this we have been using software from Matrikon. We also use from Vino, but this is a software that you can implement with any vendor. All right, it could be an OPC server from Siemens, from Allen Bradley, from Omron, from any other vendor. The Tunneler will work because OPC is a standard. Okay, if they are compatible with OPC, there is no limitation. Okay, all right, and very useful presentation. Thank you. All right, it seems there are no more questions. Thank you very much, all of you. So you have here, as I say, you have here my contact details. It will be great if you can send me an email with your feedback, with your contact details. If you have any upcoming projects where you have some doubts or whatever, feel free to contact me here to my email, f.alvarez@matrikoneurope.com. All right, so if you don't have more questions, I will say that we are done. Okay, thank you very much, everyone, and well, I hope to be in contact with you for future opportunities. Thank you.